Professor Michael Arbib, welcome to the Neuroarchitects.
Thank you.
What pulled you toward focusing on neurolinguistics and neuroscience for architecture?
They both occurred fairly late. And so with that, I became very interested in how the brain works. And then all the time I've been interested in language, I've been interested in architecture, but not as professional work. Fast forward 1979, that led us to a paper on neurolinguistics must be computational. So that was probably the first public declaration, 1979, of the neurolinguistics. It wasn't until the 21st century that my interest in architecture became a professional interest, when we started thinking about what would it mean to give a brain to a building. Once I got interested in what I call neuromorphic architecture, my interest in neuroarchitecture has three real feet, as it were. The neuromorphic, the brain for the building, the brain of the person in the building, and the brain of the architect designing the building.
So you've had a long career, and I'm sure the audience would like to know if you faced challenges because you were one of the pioneers in thinking this way.
Well, the real challenges, I think, were, and on the other hand, my mathematician friends were saying, why are you wasting time on the brain? You should be proving beautiful theorems. And it's just one little anecdote that in 1977, I got a grant to look at what's called the hedonistic neuron. And this got me to hire a postdoc, Andy Bartow, and a graduate student. And now, 50 years later, they got the top award from the Association for Computing Machinery.
In the 1990s, your group developed the first computational model of mirror neurons. The notion of mirror neurons has become very popular with architects, but you believe that their enthusiasm is excessive. Please explain.
Okay, well, this is actually interesting because it leads us into the distinction between what the architect is looking for and what the neuroscientist is looking for. So how do they connect to the visual system? How do they connect to the motor system? And so I'm aware of the fact that mirror neurons are part of a larger system. I want to understand that system. I want to understand it all. Does it matter? That's the issue. And I want to say, no, I want to understand the details. If I can just follow that through a little bit more, I'm interested in their parallel with structural engineering. And so I think with structural engineering, architects already understand that. They have to come up with saying, well, I'd like to put this here and this here, and I think this is going to balance, but do I need to add some extra metal to support this sort of thing? And then when the structural engineer comes back with all these details, they have to be able to intelligently discuss it. So I think what I'm saying with respect to neuroarchitecture is that we don't yet have many people who are experts in applying neuroscience to the problems of architecture, and we don't have many architects who know enough to ask the few people who exist the right questions. And so I think that's sort of mutual education, not the idea that architects have to know really how the brain works, but they have to know enough to pose questions. And I think the bridge is probably more at the level of cognitive science, where you can use things about how do you do wayfinding, how do you improve the light for healthy reading, et cetera, et cetera.
Mhm. Exactly. It is. I needed to highlight this challenge because we need evidence-based design, and evidence-based design takes a really long time to understand. If I say about myself, I've been working on understanding this for 15 years, and still there's a long way to go, like many of my colleagues working in this field. And we need to understand some psychology, we need to understand basics in neuroscience. That's why we need to take some short courses, as I did. We need to understand how the machines work, how we quantify our results. So it's not something that must be directed toward the marketing-led narratives. We really need these foundations that we're talking about and that you are talking about.
Let's take another example. You have people who work on glass, and how do you get glass that birds don't fly into? How do you get glass that filters out the ultraviolet light, et cetera, et cetera? And there, again, you need to know enough as an architect to be able to find the person who can give you the windows that meet your specs. But beyond that are the people who really understand light as a physics property, to understand materials in terms of what you can do with glass. And so the same way, you don't have to, as an architect, have to know the details about the brain, but you have to know how to understand what is out there and ask the right questions. And so I gave a lot of ideas about this neuromorphic and experience design of the brain of the people and the architect in the building. But I also got into the idea that the architect must, in some sense, do both. They must be an empathic, embodied being to some extent, but they also have to use language and they have to use formal drawing and they have to use computers.
You were talking about the spoken words as a language and the manual action and gesture as a language. And you've explored the language ready brain and the construction ready brain. Drawing on that perspective, what might a language ready building look like? And what could it enable based on your experience?
Wow, that's a great question because I've never actually used the term language ready building. So let's think about it. So now you take the nice twist on that and say, well, what about the language ready building? We currently have a language ready building, but we need a lot of cultural evolution to get language using buildings. So thank you for the question.
Thank you for your answer. From your experience, if an architect wants to use neuroscience responsibly, what key questions should they ask before doing their research that they will apply in architecture? In other words, what should they prioritize most when translating neuroscience research into design?
I think the problem is at the moment, you've got this sea of architects who don't know very much about the brain.
It means that even architects, not architects specialized in how to base their work on neuroscience, but they must have at least a simple notion to design something that is comfortable for people, like evidence based design. What's one design feature or the different ones, if there are many, that people assume are neuroscience based but are mostly myth?
If you think that it's just a matter of tweaking the mirror neurons, that's a mistake. So here is where the bridging expert might say, what can neuroscience tell the architect, or what can the architect ask of neuroscience?
Looking ahead, where do you think the built environment is going and what will help well being more? Technology, so in terms of AI or innovations related to sustainability, or what we call smart, or the culture and habits of how we live in buildings?
Well, sort of this encourages me to start going on a political rant because the current trend in AI is seeing a few companies develop ways of making their owners very rich and making many people lose their jobs. So it doesn't matter how well you design buildings if half the population can't afford to live in them. How can we make these new resources available to help people? And that may mean educating people to new skills. I mean, to take another revolution, so you need a political system that makes that possible. So we can say things like, it's not just a matter of your personal habits. If you have to commute more than an hour each way every day to get to your job, and that's going to put immense stress on you. My worry is that some of the people who call themselves neuroarchitects know nothing about the brain, and it's just a touchy-feely slogan. So I'd
Hmm.
say if you're going to call yourself a neuroarchitect, then please learn at least something about the brain.
Thank you.
I think that not only if you call yourself a neuroarchitect, you need to know something about the brain, but there are people out there who are interested in this, who can become those new specialists, the ones who say, okay, I love architecture, I love the brain, but how do I focus? And so one person might say, I'm really going to know everything about atmosphere. What are the ways in which light and sound can affect the atmosphere of a space? Another person can say, I'm really going to know about wayfinding. Another person, I'm really going to know about light. Another person, I'm going to measure cortisol levels in all manner of different environments so I can offer information about stress. And I think if we can have that set of architects who know enough to talk to these new specialists, and these specialists who know enough to have exciting conversations with neuroscientists, we may see the neuroscientists paying more attention to some of the questions that will enrich, eventually through these intermediaries, the future of architecture.
Professor Michael, thank you so much for this interesting conversation.
Thank you very much.
And thanks for watching us.